We've talked a little bit about taking PCs and determining the right type of equipment that we need for graphic workstations and audio and visual editing workstations. But now we need to move into a different type of workstation called a virtualization workstation. What we're talking about is the act of taking a single computer, or in some cases a single server, and using it to actually host multiple different computer or server environments. This can be achieved through different programs such as Hyper-V, VMware, VirtualBox, and all of these applications allow us to use our host computer in order to host these several different virtual computers known as guest computers. Now, these guest computers have to use some of our host computers' actual physical resources, whether it be processor power, RAM, using our input connectors such as our USB ports. All of these actually interact with the virtual computers as if they're actual physical computers themselves. But because they're inside a single physical computer, we're sort of limited by what we have in our computer as to how much they can use on their RAM and processor side. So in order to maximize the performance on our virtual computers, we want to maximize our performance on our host computer. So what's some of the specifications that we're looking for in a good virtual workstation host? Well, for a virtual workstation host, we want maximum RAM. This maximum RAM allows us to share that RAM with our virtual computers without pulling too much away from our host computer that we can no longer run processes. If we only have 8 gigabits of RAM in our host computer and we start trying to turn on 4 different virtual computers, each with 2 gigabits of their own RAM, then not only are those virtual computers going to run slowly because they only have 2 gigabits of RAM, but our host computer no longer has the amount of RAM it needs to run sufficiently. So we're going to run into problems with all of those computers. So we want to have sufficient RAM speed in our virtual machines, so we increase the RAM in our host machine. The amount of RAM we're looking for is going to range from a minimum of 8 gigabits all the way up to 16 or 32-bit. But to stay standard, we'll say we want about at least 8 to 16, especially depending on the type and the amount of virtual machines we're going to run on our host computer. We may be actually leaning toward this 16 side just because it gives us so much more of that RAM that we can dispense out to our virtual computers. Now remember that 32-bit machines max out at 4 gig of RAM. So that means that we want to make sure that our host machine is going to be at least a 64-bit machine. I don't say at least because we have 32-bit and 64-bit. We don't want it to be a 32-bit version because we only have that 4 gig max. We want to have a 64-bit machine for our host machine so that we can virtualize more computers and they can run more efficiently. In addition to having the maximum RAM, we also want to have maximum CPU cores. These additional CPU cores allow our virtual machines to run processes more. The CPUs, when they have more commands from all of these virtual machines, it's harder on the CPU. So if we have a minimum number of CPU cores, and even if they're faster CPU processors, if they're receiving more information than they're used to, more commands and more processes that they have to go through from these multiple virtual machines that we have set up, it's going to be a lot harsher on that CPU and a lot harder for it to handle. So we want to max out at the number of CPU cores that we can handle. Now we want to at least be running at 2.8 gigahertz for our CPU speed. But again, where we want to focus is our 6 cores at least. And we want to say about an 8 megabit cache. Of course, we want to make sure that it's 64-bit. Again, because our 32-bit would max out at 4 gig of RAM, which is not sufficient for our virtual machine. Now, in addition to the faster speed, our 6 cores, and our 8 meg cache, we also want to try to make sure that we're finding a processor and that we're utilizing a processor which has hardware assisted virtualization. This hardware assisted virtualization actually allows our CPUs and our computer to better utilize our resources across those virtual machines. This hardware assisted virtualization optimizes our computer for running as a virtual host. So when we can help it and when we can get the resources for it, In addition to having a maximum CPU cores, we want to run with that hardware assisted virtualization. So as we can see, when we compare our virtualization machine to our graphics workstation or our audio and visual workstation, we're really not focusing so much on having a high-powered graphics card or an extreme audio card or even an extremely strong display. What we really are focusing on and what we really want with our virtualization workstation is going to be maximum RAM, and we want to have maximum CPU cores with hardware-assisted virtualization.